All right, today we're going to begin what may turn out to be a little bit of a challenge for some of you. That will be working on volumes and surface areas of composite solids. So we will begin today with volumes of composite solids. Our objective will be to learn to describe composite solids, then calculate their volumes. Now, we've already dealt a little bit with composite solids when we were doing the activities with the little cubes where we were building shapes with other known shapes. Okay, so this will be a little bit of the same idea, although we will be utilizing a lot of the other type of solids that we have, not just cubes plus more cubes and so on. You're going to see a bunch of other three-dimensional solids that you may recognize as well. As always, press pause anytime you need more time and then hit play when you're ready to move on. Okay, so the work we're going to begin today will be the same in a lot of ways to the work we did with composite solids or composite polygons. The key to it and the secret to it is you have to be able to verbalize what it is that you're looking at. You have to be able to come up with a description of this new shape using vocabulary that encompasses other shapes that we are more familiar with. Okay, so the most critical part of solving the problems is figuring out how to begin them, and that usually means figuring out how to describe them. Okay, so I have a few composite solids here that we're going to take a look at, see if we can put a verbal description on them, and then based upon that verbal description, we will then see if we can apply some formulas and calculate their volumes. Okay, so here are some shapes. Probably want to go ahead and press pause and do the best you can to jot these things down, and then we will discuss and see if we can't figure out some names to go along with them. So go ahead and press pause, go ahead and do your diagrams, and then hit play when you're ready. Okay, so let's see if we can come up with some verbal descriptions of these shapes. So we'll start with the tower-looking yellow figure there on the left side. Hopefully, if you are going to describe this, something that should definitely come to your mind is a pyramid. There does appear to be a pyramid sitting on top of this figure. Okay, and if that is the top of this little column or whatever it is, then how would you describe the piece that's underneath? Okay, appears to be a rectangular prism. Okay, so that would be a possible explanation or description of this figure is we have a pyramid on top of a rectangular prism. So you probably want to go ahead and write that in the space underneath there, pyramid and rectangular prism. Okay, the green figure next to it. Okay, let's see if we can figure that out. I believe probably no great mystery to say that we're probably going to have to talk about a cylinder being involved with this particular composite solid. We have a cylinder on the left-hand side. And then on the right side of this, of course, it's got that pointed end to it. So we'd probably need to make a decision if we have another pyramid there or possibly a cone or what may be going on. We're going to have to assume it's a three-dimensional figure that's on there, so we wouldn't just say it's a triangle sticking out to the side, and we certainly wouldn't want to say it's a pyramid because it does not, or since the cylinder is circular, chances are this shape sticking off to the right of it has a circular base as well, so it'd be a cone. So write that underneath that guy as well. We have a cylinder and a cone. Okay, how about the light blue guy there in the middle? Okay, let's see if we can't figure out a way to describe that. Now you can see in the middle of the figure we have the dashed lines and the discolored area. It appears that something is missing from the inside of this figure, so it's got a hollowed out area inside of it. So in this particular case, we're not going to have necessarily two figures adding together like we did with the yellow one and the green ones to the left. Okay, this time we're going to have figures being, or one figure being removed from another. So it appears that we have a cube, or at the very least a rectangular prism, okay, the blue guy that goes around the outside. And it appears that we have a rectangular prism that is missing from our figure. So I think a good description for this one would be either a cube minus a rectangular prism, or possibly a large rectangular prism minus a smaller rectangular prism. One of those two things should be what you're writing down there. How about the pink guy, second from the right? Okay, the pink guy, obviously, we have a triangular prism sitting underneath this thing. And looking at the top side of that, it appears that we have part of a sphere. Okay, without more information about it, I think an accurate guess at it would be that this is half of a sphere sticking out of the top of this prism. And hopefully you remember the term for half of a sphere. That would be a hemisphere. Okay, so we have a triangular prism and a hemisphere would be a good description of that one. So jot that down, triangular prism and hemisphere. Okay, and lastly, the guy on the right side. Okay, clearly we have some type of a cube or maybe a rectangular prism. And again, you can see the dashed lines inside of there and the discolored area at the top of the figure. It appears that this figure is missing part of itself, and it kind of looks like we've got an upside down pyramid that has been removed from the inside of this cube. So my guess would be that we have a cube minus a pyramid. That would be a good description for this figure. Okay, now the key to doing this, like we said, is going to be coming up with the descriptions, which we already have, and then applying the formulas that accompany those descriptions, and the rest of it is just plugging in numbers where they belong, and that's where you come in. Okay, so we're going to make sure we have the descriptions correctly. I'm going to help you with the formulas, and then I'm going to leave plugging in the numbers to you. Okay, so these 5 questions to go along with these 5 diagrams are going to be for you to plug some numbers in, figure out the answers, and bring them to class with you. Okay, so looking at the first shape again, we said that it was a pyramid plus a rectangular prism. Okay, so the formulas for volume for a pyramid, the volume for the figures that only had one base was 1/3 times the area of the base of the pyramid times the height of the pyramid. And then for the rectangular prism is area of the base times the height. Okay, so area of the base of the prism times the area of base, or the height of the prism. Now remember that these B's and H's and any of the values that show up in any formula, those are specific to the shapes that you have in your particular problem. So the B and the H on the left refer to the pyramid only, and the B and the H on the right refer to the prism only. Okay, so figure out what values are going to belong to those formulas, plug them in, and arrive at a volume. The next figure was the cylinder and the cone. Okay, so let's see if we can figure out what's going on with those two. Shape description, again, we already said it was a cylinder plus a cone. So let's get our formulas. Cylinder is a prism, has 2 bases, so that is going to be area of the base times the height, and again those measurements for the cylinder. And the cone has only 1 base, so it's going to be 1/3 of the area of the base times the height. Okay, so same formula as the the first example that we looked at, but of course we're looking at round bases rather than polygon bases. Okay, so figure out what those values are going to need to be, plug them in, and get a volume. Okay, Next, we had assumed when we were doing our description that the larger shape was going to be a cube, and in fact it is. So we are told that the larger shape is a cube, so our shape description is a cube minus a rectangular prism. Okay, so for our formula, finding the volume of a cube is side times side times side, area of the base times the height, but with a cube it's all the same measurement, so we're going to have side cubed. And then rectangular prism, once again, is area of the base times the height of the prism. So apply the measurements from the figure into those formulas, get a volume, and bring that with you to class. All right, the next shape, okay, a little bit more complicated because of the triangular prism. Triangular prisms do tend to be a little bit tougher than other shapes of prisms. But anyway, we are told that our prism has regular bases, so we have an equilateral triangle for our base, and we are given a hemisphere that has a great circle of 25 centimeters. Now remember from our discussions that great circle means the largest possible circumference that the figure has, so that'll be where it connects to our prism. So our description, as we already said, is a triangular prism plus a hemisphere, and we will have to get a formula here for our prism. It is area of the base times the height. Hemisphere, a little bit tougher. The volume of a sphere, if you remember from yesterday, was 4/3 times pi times the radius cubed. But since we're only looking at a hemisphere, that would be half of that formula. So the formula is 1/2 of 4/3 times pi times the radius cubed. Okay. Now to figure out big B of the triangular prism, it might help you to draw a triangle separate from the figure that you have there. Label what you know about the triangular base, and then see if you can figure out the necessary information to plug into the formula. And then lastly, our shape description. We said that we had a cube missing a pyramid. So our formula is going to be, once again, volume of a cube will be side cubed, and then the pyramid is 1/3 times the area of the base times the height. So let's figure out our values. Let's plug them in and see if we can figure out some volume. So you do have a little bit of math to do before you get to class. If you want full credit for your notes, it's probably going to put those of you that wait until your last minute to do your notes. You're probably going to be in a tough spot as far as getting full credit on this one. Let that maybe be a little bit of a lesson to us. Let's not wait until the last possible moment. Let's get some things done so that we have enough time. Anyway, I will see you in class. We'll go over these problems, including their solutions, and see how well you did. See you in class.